ligand comes down and attaches itself to the G protein receptor, which then signals the inactive G protein to attach to the receptor. This then causes the GDP and the G protein to fall off, while the G protein picks up a GTP, thus becoming active. The G protein moves towards the inactive enzyme called adenylyl cyclase. The active G protein activates the adenylyl cyclase. Adenylyl cyclase converts ATP into CAMP, a secondary messenger. CAMP is usually responsible for starting a phosphorylation chain reaction. One kinase is phosphorylated after the other. The protein kinase then activates a protein, which goes over to the ER and attaches itself to the closed ion channel, which it activates, letting it open, and the ions flow. Two ligands come down and attach themselves to the tyrosine kinase receptors, which then come together to form a dimer. 6 ATP have a phosphate broken off and put on all 6 of the tyrosines. The active relay proteins come and pick the phosphates up and take them down to the endoplasmic reticulum's closed ion channel, which it activates, letting the channel open and the ions to flow out.
The use of ecstasy causes major effects on cell communication pathways in the brain and during neurotransmission, to be more specific. Normally, serotonin, which is a neurotransmitter that has major effects on mood and mental health, is released from vesicles at the end of an axon of a neuron during neurotransmission. When they're released, they travel across the synapse and bind to the receptors of the postsynaptic neuron, transmitting electrical impulses. If a serotonin neurotransmitter does not bind to a receptor, it is taken back to the presynaptic neuron by serotonin transporters in what is known as reuptake. When a person uses ecstasy, however, the substance blocks the serotonin transporters, which results in opposite effects. Many more serotonin neurotransmitters are released out of the neuron, and they remain in the extracellular area. The increased number of neurotransmitters binding to the receptors of the postsynaptic neuron and transmitting many electrical impulses is one of the causes of the short-term symptoms of taking ecstasy, such as energy rushes and distortion of time and perception. A long-term symptom of blocking serotonin transporters and preventing the reuptake of serotonin includes the breakdown of serotonin by enzymes located in the synapse, which eventually lowers the levels of serotonin in the brain and causes major effects on mental health. Treatments like ecstasy rehab help people recover by breaking the use of ecstasy, which prevents the inhibition of serotonin transporters and therefore the destruction of serotonin neurotransmitters and synapses during neurotransmission.